Hello. Again, hopefully this time will be right. So I do have 0 draw frames, so should be fine. Okay. Hopefully it will be fun this time. I'm not good with live streaming. Hello. Another coffee. No, I still have my coffee. It's still here. And I did had like 2 before. So I'm okay. Yeah, it seems to be fine. Just let me know if it's still lagging. No lag, thank you. So I think we are fine, yeah? Okay, let's go back to the power supply. What we did last, last video. We'll go together today with the short circuit protection and PCB, yeah? And we will do the PCB on a easy way, yeah? On a easy way. We'll see. No lagging. That's great. That's fantastic. Okay. So for the short circuit protection, what the people ask on the comments from the last video, we will do the easy way, like any power supply is doing, using a relay. And I do have a relay here somewhere. Yeah, using something like that. That should be fine. So we have a relay, 10 amps, 5 volts, 5 volts. Yeah, 5 volts, that should be fine. I remember I had one, a 12 volts one. Let me check. Maybe not. That's not important, you know? It's not important. If it's 5 volts, it's fine. It's okay. Hello, good morning, good morning. There's so many people here. Okay. We will use a relay. Where we will connect the relay will be on the output. Yeah, the people remind me last time we forget to move the yellow wire from the voltmeter here on the end, and we will do it this time. So the relay will be here. So here we will connect our relay. Okay? Now the schematics of the short circuit protection is simple. So these are the contacts of the relay, yeah? And the coil of the relay, we will do something like that. Plus the main voltage. And obviously ground is ground. We have a full 5 volts relay. That's what we have to keep in mind, you know. We'll have the transistor, an NPN transistor, and we will use the relay on the emitter, yeah? So on this way, so here will be the coil of the relay. to ground, and we have to regulate the voltage. So we'll use a Zener diode here. Oh, hello Britek. Just having a coffee, you know. Okay, we'll use a Zener diode here on the base with a resistor from the collector, obviously. And on the base with this one, another transistor. Connected to ground. Still the same NPN. And here a resistor which is going straight to the output. Here. Okay? And one capacitor here. We need a delay. Just a small delay. That's what the capacitor will do, yeah? So how this will work? Hello. Wow, so many people here. Just you know, feel like home and make comfortable. So how this will work, yeah? In a case of short circuit here, that means with the ground. That means this resistor. Okay, on a normal case, no, it's too complicated. Let's say in a normal case, when we have voltage on the output, we have voltage here. This transistor will be open, but open and closed means different things for different people, yeah? So on the base, I have 0.6 volts, 0.6 volts. This will be open, the current will go through, it will short this voltage to ground, so my relay will not be clicking, yeah, will not be on. So okay, these contacts are normal, yeah, it's very important because on the relay you have like the normal, without applying the voltage on coil, you have, you know, one way when you apply voltage, one when you don't. It's hard to explain, but we'll see. Don't worry. We'll see on the end because this is new, you know. I never designed a short circuit protection. So when it's short, yeah, here will be voltage. Yes, okay. When it will be short on the output, here we'll have no voltage. If it's no voltage here I will have plus 5 volts, and the transistor will it will open the relay. Bang. Problem solved. It should work. On the paper it's working, but we'll see on the real life if it's working. So we'll use 1 kilo ohm resistor here, 5 volt Zener diode, like any transistor here, well, let's say 10 kilo ohms resistor here, 22 micro here. So it should be fine. But obviously it's all about what you have at home, yeah? If you don't have a 5 volts relay, use a 12 volts one. If you don't have a 12 volts, you use a 24 volts. But obviously the diode will have different value. Depends of what relay do you have, yeah? So I have a 5 volts relay, I will use a 5 volts Zener diode. Okay? Yeah? Another question on the last video was the people, they actually don't have a big transistor like a powerful one, and they want to use two on the parallel mode. Parallel mode is like what you hear, parallel mode, base with base, collector with collector, but on the emitter you have to use a resistor. So let's say you use two transistor on a parallel mode. Collector together, and on the emitter, if you want to carry more power, yeah, base is together with this base, but on the emitter use two resistors. That's very important, these resistors. Doesn't seem important, but they are. Yeah, so on the end you have one emitter, you have one base and one collector. The resistor, I will say 0.10, 0.20, something like that ohms. Okay, now let's see. Yeah, because we are around 150 people here. Why do we need these resistors? Why these are very important? Let me see if I can. I remember someone sent me the schematics from that amplifier. Oh, it's not here. Oh, it is. So why do we need resistors there? You remember that audio amplifier? Actually, someone sent me the schematic. I want to thank you, but you know, it was too late when the amplifier was fixed. So let's have a look together, yeah? Even on the audio, this is that audio amplifier. Remember, we made 3 videos with that audio amplifier. On the audio amplifier, on the output, yeah, you have two transistors on parallel mode. You see these two transistors, and here two transistors on parallel mode. Just ignore the fact on the base we have 47 ohms, but on the and the emitters are together. But on the collectors we have 0.25 ohms resistor. You remember the big white ones? The resistor to balance the current. Why this configuration on the parallel mode need a balance? So why need a balance? You know, that's the answer. Why do we need to balance? Obviously, yeah, to balance the current. But why? Why? Why do we need? And you will find this resistor on any amplifier or any configuration when you use the transistor on a parallel mode. So why do we need resistors? No, this is not Darlington. These are two transistors on a parallel mode. Because of current. Yeah, but why? I'm using two same transistors, yeah? Like what we said last time. 2N or tip 3055, yeah? Anyone knows from the chat why do we need these resistors? Come on, people, it's simple. Yeah, ZX, yeah. But why? Why is not a balance? So I'm using same transistors here, yeah? On a parallel mode. On any device, use two same transistors. Why there is not a balance? And you have to use some resistor to balance something. What do you mean are not perfectly the same? Just what do you mean? Synchronize the gates to split the current. No, that's not the answer. That's not the answer. To pass same, yes, okay, yes, to pass same current on both transistors, but why they are not the same? Because if they will pass same amount of current, we don't need these resistors. Okay, finally someone figured it out. Different amplification. Yeah, that's the secret. Yeah? Because each transistor is same like the people. They are not the same. So the amplification factor is different. Okay? Yeah, thank you for that. So I think we are ready. We are ready to use the board. Now, when you do PCB, okay, you can do it on two ways. Oh, why? Why my stream? Why is lagging again? Why I have a error here? This is crazy. What happened with the... So the live stream is still lagging? So I got error. And I have no idea why, you know? You know when you don't have any idea? So please use a keyframe frequency of 4 seconds or less. Currently, keyframes are not being sent often enough, which will cause both buffering, yeah? It's everything is on auto mode here. Stream, no output. Video, no output. Keyframe interval seconds, 0 auto. It's on auto mode. I don't understand why we have this issue. No lag. Okay, that's fine. If it's working, it's okay. Thank you. No lag. Ajebian. Okay, let's see. So now when you are doing PCB, like how you are doing, how you put the schematics here. You can do it like on a normal way. That's the long way. Actually, you draw the schematic. You make the PCB layout. Yeah. You burn the board, and after that you make the holes. Yeah. And yeah, after that you put the components. OBS is not recording 30 FPS. This is not a recording, it's a live stream. And I do have 30 FPS with 0 drop frames. I have no idea. But I will check later. Yeah. So we can do PCB like on the old style. Actually we can't because I don't have a drill machine to make the holes. But anyway, if you are doing on the normal style, when actually you have to make the holes, when you use the PCB on the case, you have to use some things to keep the board on the distance from the anything. Yeah. But my way, you know, when you are doing something for yourself, my way, do the PCB with the component solder on this side of the board. So you will have this, you know, you can stick it with double tape on something, and the board will be protected against, like, you know, any vibration, especially on the linear power supply. Yeah, you know what I mean. Spacers. Yeah, thank you. Yeah. So you can do it on all, but you know, only when I think you have to make so many holes. That's, you know, that's enough to scare any people doing something like that. Okay. So let's do it on the, you know, on the old style. Okay, I don't have paint. You have to use some paint. You know. What's the name? Oh, anyway, I don't have paint, so I asked Diana to borrow me some, you know, nail finger fingernail paint. You know, nail polish. Yeah. So you can use nail polish. This PCB you can get it from eBay if you want to do it. Okay. So let's do the drawing fast. Maybe it's a good idea just to draw with the pen first. Polish. Yeah, Diana just okay. But just think how it's easy, you know. This is too big anyway, but let's see what we can do. So let's do first the schematic. You'll have to put this like that, so my transistor will be around here. Because I'm sure people, they will try to replicate this. And yeah. Okay, first we have the plus. Plus is here. A big plus. So we have the truck going here. This should be a big truck because it's carry current. Even if you solder the truck totally, will be fine. Good morning. Okay. What do we have next? We have the big one. So on the big one, we have like that. So we have the base, collector, and emitter on our case. So this will be tricky. You know, I haven't done this from when I was a kid, yeah? So from that point, I never done again like a PCB on the oil style. So please be patient, yeah? It's new. If it's for you, it's new. Even for me, it's new. Okay? So we have the base, yeah? We have the collector and emitter. So the base, what is the next component? We have the emitter of the other transistor. Okay, so here we can use a dot there, and our collector I should come with the truck here. Will be more easy. Okay, it's no problem. We'll come with the collector here. collector. I don't even know if it will work. If it will work to burn this PCB on the this thingy. So this arrived chloride. So hopefully it will work. Because you know the concentration of the thing it's important. So hopefully it will be fine. Good. So if here we have the base, that's fantastic because the next pin, the collector is with the collector together. So here is the next dot for our transistor. Fantastic, even better, yeah? And no, this is emitter. Okay, collector and base. And our base will be here. From this one, yeah? No, there, this one. That's the base. Good. The next one is the input. We have one oh, we need a LED. Yeah, last time we didn't put a LED. So LED should be here. Okay. With a resistor on a serial mode. LEDs are nice. Okay. And resistor, LED here. And after that ground. So we can go with ground. So what do we have next? We have this resistor. Okay. We have one resistor is going here. And next we have the Zener diode. So here it's a track. And after that we have the Zener diode. Zener here. Is going to ground. Okay, the base. On this one, we have an external one. I bought an external potentiometer. Yeah, so you'll use something like that. So in this case, just try to make it, logical. So here we'll go to the potentiometer, this one. Yes, that one. And after that we have one on the ground, which is this. And this. And the middle one. I can't put it here because if I come with the truck like that will be not okay. Not be okay. So here we have the base of this transistor. Don't worry, we can make here a spot to solder a wire which is going to the potentiometer. Yeah, I know it's long. What do you mean old school? You know what? I know this is old school, but how do you do it on these days? You know that breadboard. That's you can't work with something like that. I try to work, but it's nothing like to be clear. The fly. Thank you for the super chat. Thank you. Uh, so if you are, you try to do something like that. If you use that thing with the pins, you put the pins inside. That's nothing. It's nothing good. Actually, here you have a lot of current. You'll want to carry like up to 5 amps. What you can use the breadboard, but you have to solder each thing, and actually all the board will be like one solder. It's I think this is the easy way, because the PCB is cheap. It's the easy way to build anything, from home. Okay, that's the here, and we need this transistor. So from the base of this one, we do have this transistor. This is just a simple thing, it's nothing complicated. So you have this transistor collector here, collector, and we have the emitter and the base. Good. Next one is this big resistor here coming from the emitter of this one, and the big ones, let's put them here. One here, it's a square one, yeah. One here, and I think it's okay if we make space for another one, like that, and not like that. And that's the output. So what we have? We have the adjustable thing, like someone said in the comments. Hello? Hi? New people here. Someone said in the comments, sorry, but make a limit on the current, because it's quite dangerous to go with the current like we go last time, like over 8 amps. So because of that, we will leave this on board, the adjustable resistor, and we will use a potentiometer. I have a 100 ohms one, somehow on a parallel mode with this one, so we can set up a limit from the board, and after that we can adjust on that limit. Yeah. PCB transfer paper. Yeah, but after that PCB transfer paper, you need a program to design it on the computer. Yeah. I don't know, it's just it's a bit of headache. It's more easy to do it on this way with the schematic on your yeah. Good. So what do we need? We need this adjustable thing, yeah. Where you should put it? Here, here, here. These three things, yeah. So one is going here. The other end is going here. and the middle is going on the base. Yeah. Okay. And we have one more track from the emitter there. Yeah. Okay. We need one more spot for the voltmeter power, which will be here. Now the ground, let's take care of ground. What do I want more? This is, I want a capacitor from here. Oh, here. Let's put it here. From here to here. So this is ground. Next, we need the ammeter, but the ammeter is on the ground, will be on the end. Let's do the short circuit protection with the relay. Hello? Any people there? Thank you for being here, guys, yeah? Okay. Wait, from a capacitor from output, yeah? Okay, that's good. They should be together. Good. And after that, I said we have to put a relay. Let's draw the relay. So the relay, one more time, is not okay. One second, I'll try to figure it out. So the coil will be here. No, here. That's the coil. And we have one more here. Which I will take this out on this direction. And the next one will be this one here. And this will be our output. And will be the voltmeter spot, and that's all. Next, let's take care of this coil. So one is going to ground. One is going to ground, so this one probably. Let's come with the ground. We still have half of the board is not used. To put the rectifier bridge on the board. Oh, I didn't think that. Yeah, we can, yeah. But usually the rectifier bridge is not on the board. The rectifier bridge is on it's on a heatsink. So that's the right place for the rectifier bridge. Yeah, but like how you say, we can use this part of the board. You know what? Yeah, let's do it. I forgot about the rectifier bridge because you see, it's different part. But yeah, you're right. Okay. Good. Let's see here. The idea when you design a PCB is avoid any bridge. That's the that's the skill. Trying to use less possible bridges. Like on my case, now I need like a plus 35, and I can't take it out. I can come like that, but that's long. That's very long. Okay. I should leave here like a space so I can come with the wire. It's too late now. So we'll have like that. Yeah. We will have the emitter here. So here will be the emitter of this transistor. The next one is the collector. No, emitter, yes, collector, which is going to plus, and base. So from the base to the collector we need a resistor here, here, and here. This one. So obviously here I have to do a bridge from this point. And we have the base, and the base we have that resistor, we have a Zener diode to ground. Zener diode here. And after that we have another transistor. On another transistor we have collector. And collector is with the base, with this one. We'll have emitter of the transistor, which is going to ground, same like the Zener diode. Yeah. And we have the base, which is going to a resistor here. And here is going to the output, which is resistor, this one from here, this one. Next one, a capacitor from the base to ground, from here, a capacitor here. Good, so this is ground. Wait, what we forgot? No, everything is fine. Everything is fine. What we need two wires from here to here for the external potentiometer for current limit. So that must be the base. This one and the emitter, this one. Okay, this, it is enough space. And that's all, yeah? No, and ground. Let's go with the ground here. People. Old school. Yeah, but you know, this old school is the easy way. Like, I'm trying to design anything. In the next 5 minutes, I have the board. Yeah. Yeah, we can put a rectifier bridge on board here on the left. Yeah, let's do it. Let's do it. And the ground for the output. Sorry, and the ground for the output. Here, big ground. Good. Okay, let's put a rectifier bridge here. So we can put a rectifier bridge here. Let's say if you want to use a heatsink, or out here. Yeah, here. On this side. Yeah, I think it is space. Let's take the rectifier bridge down. And the capacitor. Now you have to keep in mind, not everyone has access on the, the new technology. Okay. Status LED is here. It's okay. That's power on. Yeah, so it's okay. I need power on LED and current limit LED. Current limit LED. That's tricky. Where is the schematic? Maybe can work on a serial mode with this transistor. Current limit LED. Signature, yeah, I should do it. Okay, let's so the rectifier bridge. Plus minus the AC. That will be AC. You know what? AC can be here. That's AC. And we have minus. We have plus. That can be ground. That's ground. That's plus, and I have to do a bridge. There's no other way. But the bridge can be from here, let's say, yeah? Plus. Yeah. So plus, I have to come with the plus to this capacitor. here and here. So this will be plus of a capacitor, here will be minus. And I will do a bridge from here. Oh, that's a very bad idea. Plus to be so close to the ground. Yeah, but, what we can do more, we can paint this and leave it for the next time. Yeah, I think that's what we will do. So if we paint this, but we can't use it because okay. So you can do halves now. You pay the other half, you burn it on the axis, and you still have the second half. Just want to be sure my circuit will be on the board. I think we are fine, yeah? I think we are fine. Hmm? Hi guys. 5 amps arc jump. Actually it will be more. It's more than 5 there. So hopefully it will not be the case. It's true. Power supply, yeah. The problem with the fan control, I ordered the fan doesn't arrive. Hasn't arrived, so I open a case on eBay. But I still don't have the fan. Maybe next weekend we can do the fan control, which is very simple. We need a thermistor and that's all. Power supply. Yeah, I know. I know, it's seems funny. But just think, there are so many kids trying to learn electronics. You know. Supply. Okay. That's fine. Let's wait a bit. Let's get the acid. It's not the acid, it's ferrichloride. We'll see how it's working. But should be quick. And we can solder the components so we can make it working. What you will do if you have to build a power supply? Because if you start doing on a, I don't know, a professional way, it's not worth. So it's more cheap to buy another one. Just to, you know, are quite cheap in these days. Messy. What is messy? The board? Board is looking great. What do you mean? Everything what I built was on boards like that, you know, drawing by hand. Of course, if you know you are a talent on the drawing, you can make it like straight. You can make it like perfect. No, not everyone is. It's you know has a good drawing skill. Maybe a op amp. Yeah, you know it's you have so many schematics there. Actually, you can modify this power supply and do it like you know in a very complicated way. But I said, you know, let's do something simple, what everyone can build and use. Try to get out of your bubble. You know, there are people they can't afford a power supply. How you'll wash the board? On the, you know, on the sink. Okay, let's try. Hopefully it's fine. If it's not fine, the solution will go behind of the paint and it will blow up the trucks. You'll see trucks are, you know, are swimming on the on the liquid. When I was a kid, I was doing something like that. Yeah. I was trying to build something that actually no. Actually, I work only on doing the things on air. Well, on the board is nice. Yeah. I just joined. Did you change something on the schematics? We add the short circuit protection. Yeah. And because you ask, I just think we didn't put a switch to cancel the protection. So to cancel the protection should be a switch here and here. But that's easy. You can solder two wires and that's all. Alpha, thank you for the super chat. You don't have to, man. You know you are there on the Discord. Thank you very much. My lunch today is covered by Diana cooking. Thank you. Hello, Sorin Rain from Holland. Yeah, I know you. Thank you for being here. Take me back so far in time. I wish, so the electronic was so simple on that time, and even late when the TV comes out, when the phones comes out. Wow, that was the best time. Thank you, Alpha. Thank you. But you don't have to. That's not the reason why we are here. Yeah, so we put a board inside. Let's put this solution. That should be fine. Should be enough. More. Yeah, that should be fine. We can reuse the solution. You see the board is getting burned right now. Let's just wait for the board. Why he didn't use a printer and a toner transfer? You know why? Because I don't know how. Because usually I'm not doing this. So last time when I did something like that was when I was a kid. Well, probably on these days are simple solutions. But what is simple for you maybe is complicated for me. So, it's not. That's what I know. That's what I know. I can't show you something which I don't know. No, actually, this is not dangerous. This is ferric chloride. This is not burning like the acid. So you see now the copper get eaten by the solution, but not what we covered. Yeah. Salute, salute. So this board is like going back 30 years. No, not 30. Yeah, yeah, yeah. What is the chemistry behind? I don't know the chemistry with this one, but I know with the nitric acid, which is HNO3, with the copper, it will give you CO4. Oh, copper sulfate. I don't remember. It's long time, It's just long time. Cup CO4 SO. No. Yeah. No. CO2 SO4. I don't remember. should go live when you're on the shop. I can't. The internet there is, you know, here is fine, but at where the speed is, it's same like 30 years ago. It's an ADSL line, very slow. Start looking good. CUSO4. Okay, yeah. Salut, Cristian. Alex, da, e diferență mare. Copper sulfate, okay. But I don't think that's the reaction. I don't know, maybe. Possible. No, man. Where is my phone? I don't think so. I don't think you're right. HNO3 with copper. Okay, yeah, I remember. Yeah, I remember. So yeah, actually you'll feel the smoke. It's a very nasty smoke. I remember. I remember the smoke, the smell. Nitrogen dioxide. Yeah, that's the smoke. And the result is CuNO3. Copper nitrate. Copper nitrate. Nitrate. Salt that form a deep blue color. Yeah, that's true. The acid go blue over a while, over the time. Thank you. Yes. Yeah. Someone figured it out. Hello. Greetings of Croatia. Praise Brazil. Germany. Hello. Welcome. Filipinas. Nearly done, yeah? Nearly done. I don't know, maybe I got stuck in time. I don't know. Maybe it's a easy way to do something like that. But most of the time the simple things are working, you know, better. Yeah, so many countries. Welcome, guys. Russia, Romania, UK, India, Philippines, Poland. We are trying to do the PCB for the power supply. Spain. We are just waiting for the PCB. Illinois, Denmark, Serbia, All countries are here. Brazil. You know, I'm so happy to see, you know, the people actually are interested on this. If you look like, you know, this kind of learning from young being, this kind of dead. You know, it's the people can't they can't learn because it's no help. Only if they are doing by themselves, checking on YouTube or buying things. But it's like no school. You have to go on a university to learn about these things. The fan control. Okay, I will show you. I ordered the fan. The fan hasn't arrived. And I open a case. Let me see if I can show you. So I ordered a fan. The fan didn't arrive, and the seller replied, "Just sorry for inconvenience," and blah blah blah. So that's the story with the fan. So hopefully when the fan will be here, we can do the fan controller. Hello. I use okay CAD. Probably it's a version of CAD. I know CAD, the program itself, to create printed circuit boards. You can draw schematics, and it's for free. Yeah, maybe I'm outdated, you know. Flagback diode. Okay, I forgot about that. Yeah, that should be there. True. Hot water warms to speed up the thingy. Yeah, possible. But it's nearly done. Nearly done. Vintage, yeah. Vintage. Old school. I was playing when I was a kid, you know, building different things. So I really don't know how the people are doing on these days. Or, you know, I think it's starting, you start ending the process. Yeah. You can see the light thing from there. It's. How do you know? You can see the copper will disappear from the board. You see the white things? The I don't know, the yellowish color? That's the board color, the PCB. Yeah, it's starting. You can see the PCB color, the yellow one. Next, you're going to hold the PCB. No, 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 no. We'll leave the back of the PCB so you can stick it on the case, and we'll solder the components on this side. You see what nice is corroded. You see, it's starting now. So the copper layer is going. It's just, you know, it's a easy way. Let's say it's a easy way, because even if you try, like how you said, you print yeah, and you photo and think, that's long. If you want to do something quick, let's say you want to do something quick. Maybe if you're doing like a, I don't know, you do only one thing and you want to do it right. Yeah, probably can be more pro. But if you are in your room and you are build things like every day, and you do a lot of circuits, so you see the copper is start going. You see the yellow thing? So actually that's PCB without copper. Nice. You know what? If you can leave some links on the comments, so actually the people there want to do something like that, but on different way, you can have a look. Because I can see people are speaking there about free version of designing PCBs. Warm the solution with a hair dryer. I think it's getting warm by the reaction itself, or maybe not. I remember on the one with the nitric acid, it was getting warm. Now, Mr. Silas, it's no problem. The live will be saved anyway, so you can see it again. My coffee is here, but it's ended. It's you know, it's just getting cold. We are just waiting for the PCB, so we can start solder the thingies. Yeah? Reminds me when I create my first distortion pedal for my guitars in high school. Thanks, Sorin. You know what? You're right. So on that time, a lot of people was going crazy, you know, creating, you know, distortion things for the guitars and audio amplifier. That was the trend on that times. No, distortion. I haven't made distortion thingy, but you know what I made? I made reverb, but you know, like on the old style with a big, you know, a big spring, a big spring, and with a speaker on one side, and a microphone on the other side, something like that. Yeah, but that was the idea. A speaker was creating a delay, the spring. That's how the reverb was on that time. Yeah, spring reverb. Yeah, yeah, it was like that. Mr. Paul, you know, if it's boring, just come back later when the board is done, and yeah, when his board is done, and after I solder the components, and you'll see the final product. So what can I do more? We have to wait for the board. I know it's boring. You think, you know, for me it's not boring. It is. It's a boring process. You have to wait for the solution to eat the copper. It looks done. No, it's still a little bit more. You know, most of the people from the chat, they are like adults, which, yeah, this kind of things is not like what you are doing on these days. But for kids, just think for kids, they are like exciting to learn electronics and build these kind of things. For kids, it's okay. Will be fun. Well, not necessary for kids. Let's say for beginners. The age doesn't matter. Yeah, it is ferric chloride. Yeah, that's what I'm using. It's from eBay. I think I paid like £4. Because you see, if you check the comments on the my old videos, actually the people try to jump over this stage, like a shortcut to electronics. I don't think you can jump. It's a lot to learn, or just from designing and just build things. Is it good for TV and laptop repair? No, this will not help you for any kind of repair. This is good for learning electronics. Yeah, nice t-shirt. I know. It's a funny one. Probably like 5 minutes is ready. That stuff is banned on Lithuania. Why should it be banned? This is PCB and ferric chloride. This is not like, it is poisonous, but it's not like acid to burn your finger. So you can put the finger inside. It's fine. Anyway, don't do it. Nearly done. Nearly done. Just a bit of patience, you know. And we'll be ready. Maybe I should put more, you know. Will be faster. And I can put it back after anyway. Finally Sunday, yes. You know what I wish to see? I want to see in the comments people leaving links from them, their YouTube things. You know, where when they build something and they use what they use, how they did it. That would be, you know, more. Would be a lot more to learn. That's what I told you. You remember I told you with the Discord. Just go there. You have on the Discord. Check my YouTube channel. There you can share a lot of anything from your YouTube, and you'll not be banned. Kate, thank you. Thank you for your super chat. Thank you very much. Just 1 minute more. You can't put you can't put links here, but you can do it on the Discord. There on the Discord, you have a special place to advertise or share your YouTube. Anyone can do it. Even if you want to grow up your channel, you know, there are like 7,500 people on Discord. So I don't understand why there are not more people sharing things. I don't understand why. Let me check. I will tell you exactly. Yes, like how I told you. Right now, yeah, right now there are like 7,547 people. A lot, a lot. You know, it's a place where you can share your things, like your videos. Mr. Bass, thank you for your super chat. Thank you very much. Yeah, you go there and you have here everything. Check my YouTube channel. Yeah, so here, check my YouTube channel. People sharing their videos. This is a great way to advertise your channel, your work and everything. Yeah. That's why I told them, you know, we need this. You know, any other Discord, if you try to share something, they will ban you. They will delete your things because it's advertised. But not there, not on our Discord. Yeah, you'll find the Discord on the description. And also, you can advertise your business. We have their thingy. You can advertise your business. I think it's ready. Yeah. Yeah, we are ready. Okay. So I'll go back in the kitchen. I will wash this. I will put this back here, and I'll come back. Just give me like 20 seconds. Yeah, 1 minute. 1 minute. I'll be back. All done. Yeah. So that's our board. You can see now it's white. Huh? So what do you think? Magic, yeah. Now let's clean it. How you clean the thingy? You clean with same things like for nail. for nail polish remover, yeah? Same thing. My luck, you know, Diana has these things. So now I just clean it. And you see, the real PCB is released. Okay. Acetone, yeah, acetone. Yeah, that's the one. Hmm. Okay, Diana said it's not very concentrated, and we have to use more. Well, it's looking good. But you know, designing a circuit, it will give you a lot of experience with the boards. You know, I know it's hard, like to think with the schematics and the components pin and design, but if you try to do it few times, you'll get experience. So even when you check a PCB from you need a protection diode for the relay. I know. I forgot about the diode. And you know, you'll get experience with working with PCBs. When actually we are looking on a PCB, or you know, try to figure it out what is there from the back. Yeah. Just one more. You see, all these small things, it will, you know, it will help you. Okay, so the board is ready. The next step is just to solder the components. Simple. So what we have, big components. First, what we have big components is the capacitor and the rectifier bridge. First. Yeah, Mr. Fred. Yeah. Burning components, yes, it will bring you a lot of experience. Yes. So even burning, you know, it will give you experience. Because if the components will get burned, you'll try to figure it out what happened there, and that's how you learn. You know what? It's not so much light here. Let me get some light. Hopefully now is better. So solder wire, we have the solder wire. Capacitor. Yeah, here we have a problem. Give me 1 second, 1 second. You see here where I done that mistake with the tracks. Yeah, that was my mistake. Yeah. Yeah, but it's fine now. So first the capacitor, minus plus, yeah? Minus plus. Yeah, for these big components, yeah, maybe it's a better idea just to have holes on the board. But we are fine anyway. Rectifier bridge, which must be here, 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 and minus. So when you design these things, you have to pay attention on this, like rectifier bridge must be on the heatsink, so you should have space to use a heatsink. So this is fine, we have the rectifier bridge. Next, let's get these components out and use them here. That's our Zener diode. I said the Zener diode must be here. Yeah. Yeah. Hopefully you can see what I'm doing here. Next one is the resistor, 1 kilo ohm resistor. Let me get one. 1 kilo. Kilo. One kilo. Yeah, I found it. Wait, that's not 1 kilo. Red, black, and red. Yeah, that should be. That's 1 kilo. Yeah, my mistake. One kilo. Red, black, red. That should be. Wait, the original schematic, we designed it with 600 ohms. I want to use 1 kilo. Yeah, that's the one. Brown, black, red. Yeah, that's the one. Brown, black, red. So red is 2-0. Brown is 1. Black is 0. Yeah, 1 kilo. That's good. That's okay. People are still here? Yeah? That's good. I know. I know it's kind of, you know, boring. So let's solder the 1 kilo ohm one. Actually, we need 2. We need 1 more for the LED. We need one more for the LED, yeah? 1 more. Same 1 kilo ohm. So the resistor will be here. And here. Next, what is next? The potentiometer is here. This transistor is next. This one. Yeah, that's the one. Hopefully the people can, you know, it will replicate this. Not necessarily on the same way like how I did it. But let me know, share a picture, you know, with your thingy on the Discord. Or you can reproduce, yeah, same thing. So we solder the transistor, diode, these resistors. Here is the potentiometer. And the next step, what is the next one? The next one is this transistor, yeah? This transistor which must be here. This is the current for the current protection, yeah? This transistor. It's a big PCB, you can see everything. So our whole schematic here can be designed on a board like this, like a small one. But just because it's big, we can see better. So emitter, collector, base, but the base should be on this side. So the transistor should be like that. So let me check one more time. The collector there, emitter there, Okay, emitter collector base, so it should be like that. Okay. So we have the big transistor driver. We have the current transistor here. The next one is the adjustable this resistor from the current sensor. Yeah, current resistor. So this should be like how? Base. Yeah, here. It should be like that. You know, in some way, I understand this. Your feeling. It's like trying to explain. Like my kid, yeah, try to explain him about how tape players are working. Yeah. You can't explain something like that, or the electronics behind of that tape player. Wow, I remember that times when actually everyone was crazy, not with the player itself, with the recording. You know, recording was something new. And most of the players, the tape players, was on the erase head. Yeah, you have a head for erase the tape. The cheap ones was with DC current, a DC small current to erase everything on the tape. But the good ones was with high frequency AC. So I like a AC power supply, a switching one with around I think 200, 150, 200 kilohertz. That was the best one. That's the way how you record like high quality. Anyway, high quality has different meaning on these days. Okay, let's solder these resistors. I soldered the wrong one. This is not supposed to be 10 kilo ohms. It is supposed to be 100 ohms. Yeah, that's the one. You need AC to wipe a tape? No, DC on the erase head. That was all the cheapest players, yeah. DC, small current, DC on the erase head. And the good ones was AC switching around 150 kilohertz. I can imagine how a DC could erase a magnetic tape. Take a magnet and put a magnet on the tape. You don't understand, yeah? Or take a magnet and put it on a hard drive, and you'll see same thing. So all the magnetic particles from the tape will be reoriented, yeah, rearranged, repositions. Was nice. And after that you have the videotape recorders and players, and there that was even nicer, you know, the way how the head is spinning and it's reading or writing track by track, and you have the sync track next to the audio one, and the audio they come out the top video tape players with the head with the audio heads on the main video head, righted on the PCM modulation, which was crazy on that time. Was like, you know, was like a was wow. PCM, yeah, PCM modulation. Yeah, so actually from like on only 30 years, you know, the humanity evolved so much. So, you know, we have iPhones, we have you know, you know, like high electronics, like I, I don't understand. I got an email yesterday, yeah, email with the Apple recall, and I don't know if it's real or not. Uh, Trash, because I deleted. I will not go to replace my battery. So there is a recall on the batteries. Bin. No, it's not. It's not anymore. I delete. I got like 2 emails for a battery recall on MacBook Pro. Fiberglass, yeah, the PCB, yeah. So let's see these big resistors. One here, and the other one here. Yeah, like that. Yeah, real-time building power supply. Yeah, but it's no rush. That's the thing, you know. Sunday, raining outside. It's just nice to be here doing electronics with you guys on chat. It's just nice. Okay. So the two resistors are soldered on the board. Okay. The next one. So there is a recall. Yeah, yeah, yeah. 15 inch. Yeah, 2015. But I delete them because I will not go there. Next one. What we have next? Let's find the LED. We need a LED. A nice LED. Yellow one. Yellow is fine or red? Let's use a red one. Red. Let's see plus and minus. It's better to check. Huh? So the LED is not working. How this is possible? Plus, minus, and nothing. I got a burn LED, it's not working. So I do have 2 volts on my... Oh yeah. Okay, this is yeah, it's going on 3 volts. It's okay, 3 volts. Plus is the long pin. Plus there, minus here. Hello. I'm happy to see here new people. So we are still doing the power supply. We just made the PCB. And also we designed the short circuit protection, so hopefully it will work. We don't know yet. I haven't tested, but it's just a logical thing, you know. So hopefully it will work. The next one, so we have this. We have two dots here. I said I will use a capacitor here. Capacitor, yes. And also I want to use the capacitor on a parallel mode with the zener. 22 micro, 50 volts. That should be perfect. Yeah. Plus minus. Okay, and one more. On a parallel mode with the zener diode. Plus minus. Done. Next, let's work on this circuit. That's all what is left, this circuit. Okay? Ionescu, da, și mie îmi place, you know, amintiri. Okay, let's finish with this one, the protection. Let's put a relay. Relay. So I did made a mistake. I think. Yes. But the relay is meant to be like that. But this pin is meant to be at the ground. This should be connected to the ground and it's not. But that's not a problem, we can make a bridge. Exact, Ionescule, ăla cu carcasă neagră, exact ăla. Mamă, câte carcase am spart. The big caps. It's not, it's just, I don't know, it's, you know. It's a normal capacitor, it's nothing special. So this is there. That's the output. This is not connected. Come on, we are close, you know. We are nearly finished. Nearly. Good, everything sorted. Next one, we need a transistor. This one and this one. Let's find them. Yeah, that's good. So here I will use a BD237. Yeah, 237, which is a NPN. I think, if I remember, these transistors are rated to 1 amp, 1.5 amps. Well, that's not a problem, because we have the relay. Emitter corrector base. So base is here, okay. Good. The next one. The small transistor, this one will be a BC109, I think. Yeah, of course we will test the power supply on the end. What do you mean? That's the idea. No fuse. Fuse is for, you know, it's it is a fuse. You can I don't. A fuse is just a wire, you know. Just, I don't know. This the transformer has a fuse anyway. Okay. My transformer has a thermal fuse, so it's okay. But you can use any fuse anywhere. On the primary, on the secondary of the transformer. Okay, so here I was wrong. If you look like the transistor like that, so emitter is coming here and it's not okay. Should be on the other side, so it's just a bad design. But we are fine. Okay, the next component will be this Zener diode and this resistor, 1 kilo ohm resistor, yeah? So we need another 1 kilo ohm resistor. Can't see much board isolation to ground. What do you mean to ground? Yeah, 1 kilo ohm here. What do you need? 10 kilo ohms here. I don't have 10 kilo ohms, but I have 15 kilo ohms. Same thing. And the Zener diode, so the resistor should be from the base to the plus 35. And I said I will make a bridge. Okay, I understand now. Collector. Yeah. So we need a resistor here. Okay. 1 kilo. So we need this resistor, 1 kilo ohm one. That's what I will use here. From here to this base. No, this is not base. 1 second. So actually the design was good. So it's emitter, base collector. Yes, no, the design is right. I soldered the transistor wrong. Okay. So now the resistor from the base to the collector. That's fine, and the Zener diode. Let me grab a Zener diode. So we have a 5 volts relay. We need that Zener, 5 volt Zener. Yeah, I found one. base to ground. So here and here. The center is there. We need one more resistor. This first resistor and the capacitor. And a capacitor here and here. $22 micro should be fine. And I think we are ready. Yep. So everything is sorted. What do we have? We have a bridge. Wait. We have to do a bridge here. From here to plus. And it's too short. Okay. It's too short. And another bridge from here to plus. Perfect. Forgot one big transistor on the top. Yeah, but I didn't forget it. It's just on the end. It's on the end, yeah? We need a bridge. Let me find a wire. I need a longer wire. Let's see. all what we have to solder is wires, and that's all. Plus here. Okay. Now the big transistor. So the big transistor should be here. Yeah, like that. Perfect. Yeah, the transistor is soldered. Let's solder the transformer wires. The AC. It's just, you know, it's about building a power supply. I'll try to put a link on description to the first video. Because you can find all components on different boards, different devices, like broken things. And you can build one, you know, not everyone has 50-60 pounds to buy a power supply, a switching, lab power supply or bench power supply. So the AC is connected. The voltmeter. Missing of yes. Yeah, we'll have to use this. So we'll use wires for this, yeah, for variable resistors. Okay, for current and voltage. So what do we have to use? Minus and plus on the voltmeter. Where should I put it? Somewhere here, yeah. Okay, well, I know what I did wrong here. So this is ground. Not this. But it's fine. This should be here. And actually this is the output. Let's solder this wire here. Okay. And after that, what is left? Is left this, which must be on the output. That's me here. My solder wire is running out. That's bad. So that's the output. That's the ground. And plus 35 should be here on this plus, or here. So now we have the voltmeter. Now let's connect the... Yeah, now we have the voltmeter. Let's plug it. The moment of truth. Yeah, we have to connect this. Well, let's see. Yeah, the LED is on. That's what is important, the LED. So the LED is on. Next one, let's solder the wires here. If we have solder wire, yes, just a little bit. Okay. I'm really sorry I missed things. Vladimir, thank you for your super chat. Thank you very much. You don't have to, you know, but thank you. Okay, so that's the voltage. This is will control the voltage. So this must be yeah. So one end must be here. The middle should be here. and this should be here. That's the voltage, and the current, this one, we need only 2 wires. Okay, let's solder these wires. So that's the current control, and it will come solder from here to here. Yeah, that's right. I think. Let me check the schematic. So we solder the potentiometer from here. Yeah, that's okay. Yeah. So we are fine. Let's connect the load, which is our light bulb. That's ground. That should be plus. So let me use 2 wires. Big wires. No one's hungry here. Okay, that's plus, that's minus. What do you mean how long the power supply will last? Like dying or how? That's minus, that's plus. That's plus. The output. And that's minus. So that's our output. Now let's connect a light bulb like usual. Let's see, if the voltage is high, it will, let me connect it to ground. Yeah, that's better. It will blow up my light bulb. And so we have a current limit. Let's change that. Or maybe it's not current limit. Something is not right. So we made a mistake. Huh? Where is the mistake? I think it's no mistake, but this. Yeah, it's no mistake. No. Yeah, so this is fine. This is the adjustable resistor on the board is made to adjust the limit. So you cannot pass the limit with this. I think. No, it's not working. Why is not working? What I'm doing wrong? Okay. Let's check what's wrong with our adjustable thing. Yeah. With our potentiometer. So this one. 3.2 ohms. But why 3.2 ohms? And on the other side, .2 ohms. And 3.2 ohms. It's not supposed to be like that. So let's check this potentiometer, the current one, which is supposed to be 100 ohms. Okay, my mistake. It's still 3.2 ohms here. From some reason. But why? Because this is on this side. This is on this side, so here should be short, yeah? Yeah, it is short. But not here. So we have a short from the middle to the emitter, yeah? That's our problem. So why? So from the base here we have a short. So it's not really logical, only if the transistor is burnt. So if this transistor, emitter, collector, base, if this transistor is burned, that can explain why we have here but otherwise I don't understand. Y BTU base and emitter, I have 0 ohms, like 2 point something. .8 ohms. So can be only transistor can be burned. Yeah, that can be. Check with the diode mode. Same thing. It's not supposed to be 2 ohms here. Well, let's check the transistor first, yeah? Transistor. So my transistor is not shorted. Emitter collector base. Base here good. Here good. What I'm doing wrong here? Because this track is not connected, the wire is not connected, and the only thing is the resistor, is this, is the adjustable resistance. There is nobody fault. Let's see now. So now obviously it's not short, so here and in the middle we have 2.8 ohms, and it's on that side, it's here. So that means this is faulty. And now with the middle I have same story, 1.7. So this is faulty. My adjustable thing, resistor, which is supposed to be 100 ohms, is faulty. So this is not good, it's not working. It's not supposed to work like that. Let's use another one. Man, 3 hours, I can't believe. This was not supposed to be 3-hour live stream. 3 hours. Yeah, maybe global warming, French fries, Coca-Cola. You know from where is this this text, yeah? Patty. Is from where on the season 1 Dexter, you know the Dexter, the serial. Dexter goes to his dead father, and the doctor from there tell him, you know, who knows what he killed him. French fries, Coca-Cola, global warming, who knows. Season 1 Dexter, yeah. Okay, let's check now. Multimeter, same spot, and we have 28 ohms, and we can adjust the resistance up to 100 ohms. What? What I'm doing wrong here? It's impossible to be all faulty. What's going on here? So here is normal to be short, but on the other side it's going to 0. How this is possible? Yes. It's going to 0 because our circuit is closed by the bulb, by the load itself. Wow. No. No, sorry. Here and here. 2 ohms is going up to oh, sorry, I'm idiot. I'm completely idiot. Obviously, it's not important where the base will be still short through this 1 ohm resistor. Uh, so you understand? Doesn't matter how you check the base with the emitter. Even if it's here, even if it's here, will be same resistance, like 1 to ohm. Ah, you see, that's a tricky one. Okay. That was a tricky one. Okay. Will be easier to use a board. What do you mean? This is a board. This is a board. Let's connect the power supply. Okay. So that's the voltage. That's okay. I understand that. And that's the current. And it's working how it's supposed to work. That's great. That's fantastic. So all what we need now, that's the voltage. Yeah, it's working fine. Yeah. The current limit. Let's limit the current. Let's say 1 amp. 1 amp. And it's working fine. Stable enough. 2 amps. 2 amps limit. Good. All what we need is this. We need a limit. So this is 2 amps. To set up the limit of the... But not now. Not now. Let's connect these adjustable resistors first. But it's working. Yeah, okay, the short circuit protection. I don't know. Let's see. Huh? The current is going up or not? Because if it's going up, no, it's not going anywhere. It's not working. The short circuit protection is not working from some reason. Let's see. So it's suppose 20 volts. Let's leave it like 15. Let's say if I short this transistor, yeah, the relay should be clicking and cutting the voltage. But it's not doing anything. Okay, now I'm stupid. You cannot short this collector with the emitter because you'll send 35 volts to the relay. Wow. Can't believe. Yeah, that's things not to do. I was thinking the relay is on the collector, but it's not. The relay is on the emitter and you have the Zener diode to... yeah, that's my mistake. And obviously was not working because we have a pin there which I didn't connect it to ground. Oh wait, what? Oh, I haven't burned anything. Actually, it's not working because that pin is not connected to ground. This one. This one. Oh, that's fantastic. So I forgot to bridge this pin. This is the other part of the coil with ground. With ground. Let's see now. So there's no voltage on the output. There's no voltage, but I will not show. I would short collector with the emitter of this one. Yeah, I heard the relay, yeah. So I will short the collector with the emitter. Wait. There's no output. There's no current going through. It's because the transistor is opened by what? No, because there's no voltage. Okay, let's redesign the schematic. All what we need here, over these relay contacts, we need a resistance. Yeah? One kilo ohm resistance. Because if the relay, the contacts are not made, this base, the base will not know that this transistor, it will not know when the short is gone or not. Okay? So we need 1 kilo ohm resistance. Yeah. We need 1 kilo ohm resistance. 1 second. Yeah, found it. Found it. It's not really clear. If the relay is like that, yeah, on the output you'll have no voltage. So actually this transistor which is reading the output, he will not know if he's still short and is 0 volts or is not short and actually should be voltage here. I will explain you on that. Just wait 1 second. So should be on the relay contacts. Let's see. So from the output to input, here to here. Yeah. Let me cut the resistance. The resistor. Mr. Jason is supposed to be a joke. Where we can use hot glue here. What's the idea? When actually we build a board. To use hot glue for what? This actually is electronic, you know, doesn't work with hot glue or praying or... I'm using hot glue when it's about to fix a mechanical fault, but not electronic. So now we have voltage on the output. Let me check a little bit what's the story with the relay. Volts. So now we have the output. And if we short the output, nothing happened. Okay. And the relay is not clicking. Let's see. Minus. Let's see what happened on the Zener diode. Short. On the Zener diode nothing happened. Output 16. On the base we have 0.6 when we short. That's the relay. That's the collector. That's the base. Okay. So from some reason, when I short the output, nothing happened. That's interesting because on the base of this transistor the voltage goes down. So now it's 0.6 and it's going down to 0. So either the transistor is burned or the Zener diode. The Zener diode is 0 volts. Okay, so we found the problem. But I still don't understand why. Why my Zener diode died? Why my Zener diode died? Because I have a 1 kilo ohm resistor here, so there's no reason for this Zener diode to die. Huh? Anyone knows? Okay, we need a diode on the relay. Yeah, don't forget about that. That's not about this transistor. It's about this diode which is on the base. Or you try to say the transistor actually died because of yeah, possible. Yeah, you can be right. Yeah, possible. Let's see. Yeah, because we didn't feed that diode. Actually, the transistor died and short the diode, the Zener diode. Let's see the Zener diode. The Zener diode is shorted, is 0, and the transistor The transistor is not dead. No, that's not short. The transistor is not dead. So actually what is dead is the Zener diode. Maybe because okay, let's find another Zener. Let's find another Zener diode. We need a Zener diode because the relay is only 5 volts. That's the reason. Yeah, that's the problem when you design things. Like you design something, you don't like just get a schematic from internet. Actually, you design one. Obviously, it's a lot of things to be tested. So this is another Zener diode. Hopefully, it will not get burned, but who knows? Let's see. It's very important to see what's going on here. So I have no voltage on the Zener diode. Let's short the things. Yeah, we have 6 volts on the Zener diode when I short this. But on the relay nothing happened. And on the base of that transistor, of the relay transistor, the voltage is changing. We have 6 volts, but nothing happened on the output of the on the emitter of the relay, the transistor. Nothing happened. So we have 0. So actually even the transistor is dead. When I have on the base, I have 5 volts. On the emitter should be 5 volts also. 1 kilo ohm is fine. I have 6 volts here on the Zener. I have 6 volts, but I have nothing on the emitter. So I think we need a flyback diode. Let's check the transistor. Diode mode. Yeah, nothing. No, it's just dead. It's interrupted. It's not shorted. It's interrupted. Okay, the transistor is dead. Let's get another one. Let's try to use a diode, like flyback diode. Because that's switching, it will kill the transistor. Actually, the inverse voltage of the coil, it will kill the transistor. Relay problem? No. Emitter collector base. No, the transistor was fine, but you have to understand. when you have a relay and it's switching, the inverse voltage will be higher compared with the normal voltage. Someone said use a diode, flyback diode, and I said, you know what, maybe it will work like that. Well, I don't think so. I think we need a diode. So we'll use a diode. Let's see, we do have one. 1N something, I don't know. It's not even important. So from the emitter to ground, yeah? Yes. With the plus to the emitter. The transistor burn when you want to test the relay by shorting the you can't burn any transistor, yeah? You can't burn it if you short emitter with collector. You can't. You can't burn a transistor shorting the emitter with the collector. You can burn different things, but not the transistor. Okay. Let's see now. That's crazy. That's insane. So what we did wrong? Emitter, collector, base. That's crazy. That's insane. How a schematic like that cannot work? So we have an NPN transistor. People are laughing on the chat. I can't believe. Yeah, it's funny, you know. It's funny when you don't know what happened. What happened here? It's not supposed to happen. So what I did wrong? It's not supposed to happen. It's a simple schematic. It's a transistor. It's basic. People can't wait to fail. Can't believe. Okay, things happen. Let's see what get burned here. Transistor, it's 100% burn. So you understand, it's this schematic which is supposed to work. It's not like I did something wrong. No. You see, that's the schematic. There's no point checking the transistor. Let's check the diode, the center diode. Is still alive? No, the center is shorted. So is something wrong with my design? Too much current. Current from where? From where? It's a relay. The relay is still good because the relay is shorted. The relay is 0. So the relay died from the last time. Yeah, that's my relay. Or this diode died. 0. Okay, let's get the diode out. Wow. It's not working. Yeah, it's because Sunday. Yeah. It's because Sunday. Now let's check the diode. The diode is good. The relay is shorted. So on the relay coil, I have 0.8 ohms. Can be good. Not today. Yeah, Diana will sort it out. Yeah. Flyback. You listen to me, yeah. When you have a flyback diode in the inverse direction, so yeah, it will blow up, but it's not the case. That's the diode. That's the plus. You can see the ring there. Plus is here, minus is here. This is ground. In Zener diode, there is too much current. Okay, too much current on the Zener diode, the Zener will get shorted, but it will not blow up the transistor. Yeah, that's how a Zener diode is working. So what's the problem with my schematics? Yeah, just I want to see, the capable people from the chat. What's wrong with my schematic here? What is wrong? Relay shorted. That's what I think. Relay shorted. Flyback acting as a self-defense. Nah. I think the relay is shorted. I think. I'm not sure. Let's show you the power supply. I have the power supply here. 5 volts. You can't see the power supply. 5 volts minus plus 2 amps. 5 volts, 2 amps. The relay is gone. Don't worry, I'll find another one. But you see, like a case where actually everything should work, because that's how you design it. You design it to be working, and it's not working. Can happen. We don't know why. Because, yeah, maybe because I didn't feed the diode in the first place. But still, that doesn't explain why the relay got burned. Let me find another one. Let me find another relay. Bad things can happen. What do you think? You think it will not happen to you? It will. I found one. 10 amps, 12 volts, yeah? So you'll use a 12 volts relay on the same configuration. That's karma. That's karma. Yeah. Karma got me. You know, I'm working Sunday. So let's do it right this time, yeah? Like first time. Why my fuse didn't protect my thing? Okay, so what is changed now? Now we have a 12 volts relay, so we have to use a 12 volt Zener diode. Yeah? 12 volt Zener. So it will be higher voltage. Hopefully the explosion will be more spectacular, you know? I still don't get it where I'm wrong with the schematic. It's a basic one, should work fine. 9.1 volts, maybe. Ten volts, even better. I think it's 10 volts. 13 volts. Okay, I found 13 volts. That should be fine. Check tranny again. May have popped. What do you mean? Which transistor is burned? It was smoking. That's gone 100%. $13. Okay, so we do have a Zener diode. Let's solder the Zener diode. You know, this can be burned, but I don't know. We'll see. Okay, you need another transistor because this transistor is dead. This is the burned one. Funny. Okay, let's check the resistance of the relay. Like, what's going on there? This and ground, yeah? 400 ohms. So again, we are using a transistor on the same way, on the same configuration. There's no reason to blow up. But who knows? Who knows? So the transistor is soldered on place. Now, who want to plug in the power supply, huh? Let's plug it, yeah? Just be careful, yeah? Okay, nothing blow up. Nothing is... Let's check the voltage on the center. So it's 0. Let's short this. It's working. I can hear the relay clicking. When I short, let's try. Let's see. So when I short this, everything goes to 0. Yes, everything goes to 0. Okay. Let's use a load. Okay, that's not good. So why it happened even with a load? Interesting. What we did wrong? Yeah, Mr. Greg, yes. Bulb making the relay to engage, but why? Because there is no short, it's 16 volts. So my input on this transistor is playing. So doesn't matter if it's short, but the relay is acting. Why? Why? 1K resistor. This one, that's what I was thinking. I was thinking 1K is too high. Should be less. There should be a logical explanation. Bulb is a wire. Bulb died. No. Bulb is fine. So again, if I short, let's see what should I short. If I short base emitter here, I should have light on the bulb, and I don't. Okay, emitter with base, emitter with base. Okay, base, collector with the emitter. Yes. So if I short collector with the emitter, I have voltage. I have output. If I short collector with the emitter, does mean my transistor should be open. It is open, but not with the bulb. Wait man, something is wrong here. So now I do have voltage on the output, 16. Yeah, but what voltage is this? Is from this resistor? 1 second, give me 1 second, let me take this out. This 1 kilo ohm resistor. So the resistor is out and I do have voltage. And obviously now it's nothing. Let's check the small transistor. Let's check that transistor, the small one. Base. So what's wrong with our circuit here? What is wrong? Anyone knows? The problem is before the relay. What do you mean? It seems the transistor connector is PNP. How this can be PNP? It's BC109. It's not PNP. So everything is working fine till the point I connect a load. No, that 1 kilo ohm is fine. There's nothing wrong with 1 kilo ohm resistor. That's actually fine. Okay, let's try to connect 2 bulbs. Let's try like that. Transistor need potentiometer to be less sensitive to short? No way. Let's check with the multimeter. So on the base I have 0.7, which is fine. It's connected. So now if I connect a load, let's raise the capacity of this capacitor, yeah? Let's see. The truth is when the light bulb it's off, the resistor is very low, so it's possible to take more current on the beginning. That can be a reason. Let's try with a bigger, higher capacity. That can be a reason. But we have to find the problem. Let's see, it's working now. Yeah, what I told you. So you see now it's taking, how much is taking? Let me get our other bulb. You see on the beginning I told you we have to create a delay. We have to create a delay. Because if you have a low ohms load, it will take like it's a short. Well, actually it's no short. So let's see, now we have a current limit. Okay, short this and it's going to 0, you can see. So now I have no current, no voltage. And yeah, the load has to be disconnected because that's the way how they are working. It's working short and it's going to 0. That's a short circuit protection. Okay, now we disconnect the load. The voltage is coming back short and it's going to 0. Okay, disconnecting, the voltage is coming back, it's working fine. So it doesn't matter how many amps, we can set up more amps. .6 amps short is going to 0, you can see 0 there. Yeah, disconnect, it's working fine. Connecting, it's working fine. Short is going to 0. That's a short circuit protection. Okay, so you understand what's supposed to work from the beginning. So actually that smoking things, it was not supposed to happen. I don't understand why that happened, because the schematic is clear. Okay, so I think I'll stop now. So even now, like you have now 16, if I short the wires, I will short without the bulb. Short is going to 0, so it's working fine. I can hear the relay clicking. So if you want like a protection to enable and disable this protection, use a switch on a parallel mode with this resistor or with these relay contacts here. You know why? Why you should use here? Obviously you can disable doing anything here, but just because even if you use a switch here, you still can hear the relay clicking when you have a short, and it's helpful when you try to diagnose things. Yeah. Use a smaller resistor for what? For what I should use a smaller resistor? So now we do have, you know, what the people ask, the short circuit protection. And actually it's working, and it's short and it's going to 0. That was supposed to work the power supply, the first one which I bought it. You remember? On that first video, even now, you know, people leave a lot of comments. So that's how a power supply with short circuit protection is supposed to work. And it's a simple circuit, you can see. It's a simple one. Okay? The capacitor set the sensitivity of the short circuit detection. The capacitor just give you a delay. Let me explain you. So here on the base here, without that capacitor here, you'll have something like that. And the transistor can get this like, you know, it's a short, actually, when you have a load. The capacitor, it will give you something like that. Because it's charging, it's getting charged, and it's this is a delay here. A delay for this transistor. Okay, so the fact the transistor is getting charged, our transistor is 220 micro. The diode is now 12 volts, the relay is now 12 volts, and we have a diode here now. This diode is 1N4007. The relay is 12 volts relay. The transistor, this one, it's a BD237. This one, it's a BC109. And this resistor is 1 kilo ohm. Okay. Yeah, okay, everything sorted. I'll stop now because I'm hungry, you know. I can't believe. Wow. It's like 4 hours. And you know what? I think we can see next Sunday, and we can work more on the other things, yeah, on the fan control. But yeah, that's what we did today. You know, the board with you know, looks dodgy, but it's working. Okay, I'll try to sort it somehow to make it more clear. Okay, it's not 30 volts. I think it's 24 volts I have on the center diode, so probably the voltage will be like 22. 22, yeah, it can be 5 amps. We can remove the... okay, I think it's something wrong with my internet. Anyway, thank you for watching. Like and subscribe if you like the video. And see you next Sunday, yeah? Next Sunday, we'll start doing more. Okay? Have a great Sunday. Schematic, post schematic. That's a schematic. You know, just pause the video and see. Okay? That's great. Thank you guys. See you next week, yeah? Bye.